I've got a home office setup that I like. It has a Thunderbolt cinema display set up with an older MacBook Pro, and I really liked how I could just connect to everything using these two cables. The Thunderbolt 2 cable and then the MagSafe charging cable worked really well. And then the monitor actually has another Thunderbolt cable that went down to a hub that had lots of other ports and connections made on there. Now I've got a new laptop. It's a 16-inch MacBook Pro M1, and the goal here is to see if I can figure out a way to connect to this new computer, which only has USB-C and a new MagSafe 3 connector on the sides. And this cable is worn out anyways, so it's time to do something about it because it was intermittent. So that's what I'm going to do here, is figure out how to make this older Thunderbolt display monitor connect to a newer MacBook. In my case, I use a monitor arm instead of the original Apple stand, and there are plenty of videos online for removing the Apple stand off the back of this monitor, so I won't go into that, but it's also not required for what I'm going to do here today. This is obviously the back of the monitor. You've got power here, and then the combination cable with MagSafe and Thunderbolt 2 connects out of here. I've actually already removed the screen on this one. There's plenty of videos online for that as well, so I'm not going to go over those steps. But with the screen removed, this is the inside, and basically what the connections are very simple. There's power over here, and that goes through to the MagSafe plug, and then underneath here is just a regular Thunderbolt 2 connector, and the power plus the Thunderbolt 2 connector go into a single umbilical cable, but really it's just power and Thunderbolt 2 running side by side. So I'm going to open this up and see how I can retrofit into those. The first step is to remove this cover, which has 3 screws with T10 Torx heads. Next I'll remove this power connector, and then I'm going to start peeling back this tape so that I can start uncovering the cable that goes out the back. Next I need to remove this logic board so that I can get to the Thunderbolt 2 connector, which is on the other side. It has a lot of little connectors that are pretty fragile, and then this big one at the top as well. So I'm going to remove all those connections and remove the screws, which are also T10 Torx. I've removed this logic board that has the Thunderbolt 2 connector on it, and as I mentioned, there's lots of little small connectors on it, so you have to be pretty careful when you take those apart. The good news is Apple's made it so that you can't get the wrong plug back into the wrong place on the board when you go to put it back together, because they all have a different number of pins. The next 2 screws I needed to remove turned out to be T6 Torx heads, and they hold down this cover, which also locks in the Thunderbolt 2 connector. So I'm going to lift slightly on the rear of it and just pull it out of the port. And now the umbilical that has the MagSafe and Thunderbolt 2 is actually completely free from the rest of the case. Now I have access to the Thunderbolt 2 port that's on the logic board, and the only trouble with it is that it's designed to use this extra long, extra skinny connector that was in the original cable. I'm planning to use one of these just regular off-the-shelf Apple Thunderbolt 2 cables, and it won't fit because it's got this extra thick plastic surround on it. So unfortunately it won't fit as is, but if I remove this lower clip, it actually will fit. And then I just have to come up with some method of strain relief so that that doesn't get pulled out. My plan is to use this short Thunderbolt 2 connector along with the Apple Thunderbolt 2 to Thunderbolt 3 adapter, and once that connection is made, now I'm dealing with the USB-C style connector that's on my new laptop, and I'll either run this short cable out the back of the monitor or keep this whole thing inside the monitor and then find some sort of extension cable to run this down to my laptop. The trouble may be finding an extension cable for USB-C connectors that has the full Thunderbolt 3/Thunderbolt 4 functionality. For securing the Thunderbolt 2 cable onto the Thunderbolt 2 port on the logic board, I just went with regular old hot glue. It's simple and effective, and it holds it very securely. Plus, if I needed to, I could remove it. I found this Thunderbolt 4 capable extension cable online, and it's long enough that it opens up the possibility of having this cable actually plug in inside the monitor and then extend out the back and still be able to reach down to my computer below. So it's time to figure out how to route this Thunderbolt 2 cable inside the monitor. After a lot of experimentation, here's what I came up with. The Thunderbolt converter lives right here, and it's attached to the back of the case with some double stick foam tape. So with that secured, then the Thunderbolt 2 cable wraps around in some natural recesses under the logic board, which flips over. The cable exits in this little opening here. And with that done, the board sits all the way down. And the Thunderbolt 2 cable, as you can see, is free to move. It's not pinched between any of the components on the other side of the board. That leaves the USB-C style connector on this Thunderbolt adapter exiting right here, where I can attach it to an extension cable, which has plenty of room to come out and make a soft arc out of the back of the monitor case. All that's left on the video side of things now is to reattach these connectors all around the board and to screw it back down with all these little tiny screws. Don't install a screw back in this hole yet. That's used to ground the LCD flat panel when reinstalling it. With the conversion complete on the video side, now it's time to switch attention over to the power side. This is the supply cable for the original Apple MagSafe power connector. And it may be hard to see, but there's actually 2 pins inside this connector. Now I connected my digital multimeter into these 2 pins and fired up the monitor, and I didn't see any output at all shown on the multimeter. So through some experimentation, I found out that if I attach a 10K resistor across these 2 pins to create some load, then the meter would show 16 to 16.5 volts. The next step, I cut off this portion of the original umbilical cable so that I could reuse it. So the plan is to plug this in, and then using the original power wires, I'm going to try to use this voltage conversion module that I found on eBay. Now what this does is accept between 6 and 35 volts DC, and then it can output any number of these different power protocols. Power delivery is what I'm interested in, and I plan to use the USB-C connector that's on the back. Basically, this is a buck converter that takes in the DC voltage and then steps it down to whatever level the connector or the device on the other end of the connector has negotiated with this module. So this also contains the circuitry needed to do that negotiation. What remains to be seen is whether this charge module will create enough load either on its own or with the MacBook plugged in to turn on the charge circuitry on the original Thunderbolt display. And then the other question is how much power it will actually supply to the MacBook. Out of an abundance of caution, I just want to see what happens when this charge module is initially turned on. It's got some caps on the input side, and so I want to find out if there's inrush current of any significance. So I've got my homemade variable power supply set up, set to 16 volts, and then I've got this meter set to capture the maximum current that flows through it. And on the output of the charge module, I've just got one of these USB testers. So I'm going to go ahead and turn it on and see what the maximum current is that flows. And it looks like only about 8 milliamps. Not a big deal. So I've got the phone which is taking this video plugged in, and I'm running the power through this USB-C tester from the USB-C port on the charge module and into this phone. So let's try it out. So it looked like there was no significant startup current, but it quickly switched to a charging mode. And right now this phone, it just switched from 5 volt charging to 9 volt charging in about 13 or so watts. And that matches with what the power supply is actually putting out. And as a final test, I've got my MacBook actually hooked up. So I'm going to run the test again. We're still set to 16 volts. So I flip that on. The laptop just started charging. Now it is at 100%, so it's not pulling any significant current, only about half an amp. But if I refresh the power information page, it says it's connected to a 45 watt charger. So that's at 16 volts. The laptop reads it as a 45 watt charger. Now if I turn this up to say 24 volts and refresh, it actually does appear as a 100 watt charger. Unclear if this charge module can actually deliver 100 watts of power to the laptop if it had a lower state of charge. Here's my simple setup for trying out the Thunderbolt Display power supply with the USB-C charge module. So as you can see, I've got the power supply wired into the breadboard here, and then I've also got my multimeter plugged into the same side so I can watch what the voltage is on the power supply. I don't have the charge module wired up yet, but I'm going to start out by just turning on the monitor, so I'll do that now. And with the monitor powered on, you can see it's outputting about 6.7 volts. So next, I'm going to insert this 10K resistor to put some load on the power supply. And you can see when I did that, it took the output up to about 16.2, 16.5, 16.2 volts. Now I'm going to connect the charge module over to the power supply with some jumper wires. So I'll just connect positive and negative. Starting with the negative. And there's the positive wire. Okay, so you can see the voltage has dropped quite a bit. It looks like we may have a problem with the resistance. It looks like I'll have to play around with different resistance values to make the power supply stay on when the module is actually plugged in. After quite a bit more research online, I think I have a solution for how to power this charge module using the original Thunderbolt power supply. I'm going to go ahead and turn on the monitor by plugging it in. Now earlier I used a 10K resistor across positive and negative to bring that up to 16.5 volts. And 10K wasn't actually the right value. One thing I found online is that the way this power supply works is it's expecting a Mac on the other end to apply a resistive load of exactly 39.4K ohms. So I have such a resistor here, and the first step is to plug that in. Applying the resistor across positive and negative from the power supply. And now again we get about 16.5 or 16.6 volts. That's great, but unfortunately that still won't power the charge module as is. Through a lot of experimentation, I found out that what I needed was actually a diode between the positive of the power supply and the positive side of the charge module. So if I take the positive lead here and connect it to the anode side of this diode and have the cathode of this diode connected to the positive input of the charge module, you can see the charge module turns on and the power supply voltage stays roughly where it was, right around 16.5 volts. Now let's go ahead and change the voltmeter over to measure the output side here, or in other words, to measure the voltage that's going into the charge module. So as you can see, the voltage going into the charge module is right at 16 volts. There was a voltage drop by going across this diode, and there's two problems with using this diode. One is that it's just a 1 amp capability diode, and that's not going to be enough to handle the power that I'm hoping this display will be able to supply to my MacBook. The other issue is that this 1N4001 diode has a forward voltage drop of up to 1.1 volts, and that's fairly significant. That might be enough drop to where the charge module isn't able to support some of the higher speed USB-C charging modes. So I rummaged through what I had lying around and I found this. It's a MBRF 10100C Schottky diode. It's rated at up to 10 amps, and being a Schottky diode, its voltage drop is almost about half of what this 1N4001 is. This can have a voltage drop of just 0.65 volts. So I'm going to go ahead and switch it over to this other diode. And there we go. So now even flowing through the diode, which is capable of 10 amps, we still have 16.3 volts as an input to the charge module. With the charger module now running through this diode that has a higher current capacity, I can go ahead and try to test out the charger and put a real load on it. So to do that, I've got this USB-C inline tester, and on the other side of it is the phone which is recording this video. So I'll plug it in, and we'll see what happens. You can see it starts charging at 5 volts, and it quickly switches up to 9 volts, just like you'd expect from a USB-C charger. It's now up to about 15 watts that it's charging this phone. Meanwhile, the voltage on the input from the monitor power supply is holding steady. The next step will be to figure out how to package this breadboard setup into something that I can stash inside the monitor and just run the USB-C cable out the back. Here's the finished charge module. It's got the 39.4K resistor attached between the two leads that come from the monitor power supply. And then in the end, after searching all over this module for the best place to insert the diode, I ended up putting it in the unused USB-A port there on the end. It turns out it fits really well. It also lets the diode make a lot of contact with a sort of heat sink, and it was the most out of way place that I could find to put it. So in the end, I stuck it in there, as strange as it looks. The positive cable comes from the supply up to the diode up front, and then the output comes from the diode, heads back again to the positive connection on the board. Pretty straightforward, and I think it'll work pretty well. So let's go ahead and try it out. I've got my multimeter hooked up to this module just to see what's going on. Okay, there, it's on. And as you can see on the meter, it immediately went up to 16.3 volts where we would expect. Here's the moment of truth. I've got a USB-C cable plugged into the MacBook, and I'm gonna go ahead and see what it does. The red light came on the charging module, which is the light that means that it is charging. And we see the voltage on the supply powers dip down. That's not surprising. Lastly, I did actually hear the MacBook make the noise like it's been connected to power. And though it's hard to see, battery status says power source power adapter. And now I can refresh the hardware profile and look at the power information. There we go. AC charger information, wattage, 45 watts. Of course, 45 watts is quite a bit below what this MacBook's MagSafe 3 charger can do. But for just sitting at a desk plugged in, which is how I use the laptop 90% of the time, that should be just fine for maintaining a charge and slowly charging it back up when I do have to disconnect it. So the next step will be to wrap this in Kapton tape and make sure it's well insulated and no possibility that anything can short out. And then I'm going to find a place in the monitor case to mount it. Here's the finished product. The charging module fit nicely into this little area here, and I was able to add a heatsink on top of the USB port, which is pressed tightly against the diode inside. So that should help with cooling, as well as this is the fan, and it blows air, forces it down through these areas and out the vent at the bottom of the case. So I don't think cooling is going to be a problem. But with the video side completed over here and the cable routed behind, and the way that the power charging module worked out on the left side, I'm pretty happy with how everything went. And I've got the two cables run out the back. They're the same length, so I'll be able to run data and power down to my laptop very similarly to how the monitor was originally designed. Next step is to put the screen back in and try it out. To verify the real-world charge rate, I've got this little meter plugged in, and on the input side is the USB power delivery from the Thunderbolt Display, and then this output cable goes to the laptop. And the laptop's not charging right now. It's got looks like exactly 10% state of charge, and at that level, the laptop's gonna pull the maximum current from whatever power supply is plugged in. So let's go ahead and plug this in to one of the USB-C ports. And it looks like power delivery immediately negotiated the 15 volt charge level at almost 3 amps. So right around 42 watts of power going into the laptop. And the laptop did make the sound and shows on screen that it is charging. Let's go and refresh the system information. Sure enough, it's recognized it as a 45 watt power supply. So that's pretty cool. It's acting just like any normal charger would. So at the 3.5 hour mark, the Mac is fully charged, and according to this meter, it took 137 watt hours to go from 10% where I started recording to fully charged, and that's on what Apple says is a 100 watt-hour battery. So 137 watt-hours to charge a 100 watt-hour battery, although I had the Mac running and running iMovie and browsers and lots of apps while that was going on. So we're down to the point where the charge is down to just 1 amp. We'll see what that is. Down to 16 watts on a 45 watt charger, whereas Apple ships these with a 140 watt charger. So I'm pretty happy with that. 3.5 hours to charge up the battery almost fully while using it is not bad. As a final step, I inserted this grommet where the MagSafe and Thunderbolt 2 cables used to exit. And that should help protect these new USB-C based cables from any chafing or getting cut as they exit around the corner of the aluminum on the back of this first monitor. And I say first monitor because during this project I was able to find a second monitor which needed a new panel and a new piece of glass on the front. And after replacing those, now I have 2 matching Thunderbolt displays on a single arm that go up and down together. And I was able to use the display that was on this part of the arm as a third display. Now these first 2 displays are Thunderbolt compatible out of the box. They daisy chain together no problem. But then I have the second monitor connected via Thunderbolt cable under the desk to a Thunderbolt hub that spits out USB. From USB, I'm able to connect this display link adapter, which goes to DVI and connects up to my older DVI based monitor. So all 3 of these are connected together and connected to the laptop through the single Thunderbolt 4 connection. And I'm pretty excited about that. 2 Thunderbolt displays at 2K resolution, as well as a 1920 by 1200 display, all over 1 cable. I hope that's helpful to anyone who might consider making the same conversion. Thanks for watching.